Alicia, and some of you might not know me because I've been away for the past 2 years. I was most of my time in Brazil, and that's where I carried out 3 greenhouse experiments working with biochar. For this talk, however, I will be showing some background research, some background on my research, and showing some results of the first experiment, which was a bit of an exploratory experiment leading up to the other 2. So this talk is titled Biochar Feedstock and Pyrolysis Temperature Effects on Maize Cultivation on a Brazilian Arenosol. So my research site was, as I said, in Brazil, in the state of Mato Grosso, shown in the red square, more specifically in the capital city of Cuiabá. Cuiabá is located in the Cerrado region, which is the Brazilian savanna, and this biome is characterized by shrubland, grassland, and some forested areas. But since the main economy of the state of Mato Grosso is agribusiness, this natural vegetation has been replaced by pasture and croplands. The main crops in Mato Grosso are soybean, so there are very extensive soybean plantations, followed by maize and cotton plantations. In the map in blue, you can also see arenosols, areas that are covered by arenosols, and these arenosols are very sandy soils. They cover 30% of the state of Mato Grosso. And these soils are of interest because most of the maize produced in the state is grown on these soils. And in the last 10 years, maize production has grown tremendously, and it's only behind soybean production. So it's a very important crop for the economy. So maintaining these soils is of interest to local farmers. However, arenosols are not really very good for agriculture. They're not very nutrient-rich soils. They are derived mainly of quartz materials, which do not retain nutrients very well. They are very sandy with a low water holding capacity, and they have low organic matter content, which affects the water holding capacity, and so nutrients leach very easily from these soils. So overall, these soils are very poor. However, a way to improve these soils is by increasing organic matter levels in the soil. And this can be done by adding organic amendments, such as compost or green manure, mulch. And these amendments are fine, but they decompose very quickly, especially in hot climates such as Mato Grosso. So they have to be added every year. So another organic amendment that's more stable and more resistant to decomposition is biochar. Biochar is charcoal derived from waste biomass through the process of pyrolysis, which is heating biomass at very high temperatures in the absence of oxygen. And biochar is specifically made as a soil amendment. Biochar is not something new. It's been around for hundreds of years, but only in the last few decades has there been increasing scientific interest in it. And many studies have shown that it has potential to increase soil water retention and carbon sequestration in the soil. In addition to these improvements to soil conditions, biochar also presents a good opportunity for waste reduction. So besides soybean and maize production in Mato Grosso, there are many other agricultural industries, such as raising pigs, so swine production, sugarcane plantations, cotton, and eucalyptus plantations. And all these activities produce large amounts of residue, of crop waste. So these residues can be added directly to the soil, but just as they are, but they can increase decomposition rates and so increase carbon emissions, and they also pose, there may be risk of nutrient leaching, and this can contaminate ground or surface waters. In the case of swine manure or pig slurry that's added directly to the soil, there can be risk of pathogens. So transforming these materials into biochar through pyrolysis, heating at very high temperatures, this eliminates pathogens, and it also dramatically reduces the volume of these materials. So in places such as Mato Grosso, where agriculture is intensifying, more agricultural production leads to more agricultural residues. So transforming these to biochar can help reduce these materials and is also environmentally beneficial. So as I mentioned, I had 3 greenhouse experiments, and each of these experiments had its own objectives. The first experiment was a biochar type experiment, where we wanted to observe the effect of biochar type on maize biomass, dissolved organic carbon, DOC, nitrate, NO3, and water retention. For the second experiment, we were looking at the biochar doses, We wanted to determine the optimum biochar dose for maize production. And for the third experiment, we were looking at water deficit. So we wanted to see how biochar could contribute to water retention in soils with different levels of water deficit. For this talk, though, I will only be showing some results of the first experiment. So to explain a bit why we were looking at these variables, for maize biomass, we wanted to see how biochar type could affect maize growth. And we weren't necessarily expecting to see biochar increase maize biomass compared to soils with no biochar. We mostly just wanted to see how the different types would affect the maize biomass. We also wanted to see how they affect water retention, so how much water would be available in the soil, and this would affect plant growth. And for DOC and nitrate, first of all, carbon is what gives structure, stability, fertility to the soil. But carbon can be lost in several ways. It can be lost in the form of the organic carbon in litter and roots, branches, crop residues when they're removed and used for other purposes. So the carbon is removed from the system, the material is not decomposing and returning to the soil. Carbon can also be lost as carbon dioxide, CO2, returned to the atmosphere in the processes of respiration and decomposition. And it could also be lost as dissolved organic carbon. So DOC can leach further down into the ground where the plant roots can reach it, or it can be washed away in runoff. Nitrate is often added as a fertilizer to the soil, but it too can be lost. It can leach further down, or it can be carried away in surface runoff, where it can be a source of pollution for aquatic ecosystems. So it was of interest to see how these biochars could help retain DOC and nitrate in the soil. So we had 12 biochars commercially made from 4 feedstocks, so 4 organic materials locally available in the region. These were cotton husks, eucalyptus sawmill residue, sugarcane filter cake, which is a byproduct of the sugarcane distillation process, and soy manure. And these were all heated at 3 temperatures of pyrolysis, 400, 500, and 600 degrees. So 3 temperatures times 4 feedstocks make a total of 12 biochars. Here you can see what the biochars look like. It's hard to tell the difference, to see much differences between them, but because we crushed them and tried to make the aggregates the same size. But you can see, visually there were differences between the feedstocks. Between the temperatures, you can't see any differences. But structurally, as you increase the temperature of pyrolysis, the structure of the biochar becomes more stable, more resistant to decomposition, and the porosity can also change. So this can affect the water retention. So we wanted to see how the biochar feedstocks and the biochar temperatures would affect soil conditions and plant growth. So the soil we used, as I mentioned, was an arena soil collected in the Cerrado region on a farm called the Fazenda Agua Azul, a large-scale farm run by the Grupo Buen Futuro in the city of Campo Verde, Mato Grosso. The soil texture was very sandy, 91% sand. The CEC, which is the cation exchange capacity, which is a measure of nutrient availability in the soil, was 5.3, which is low. So the higher the CEC, the better, the more fertility. And the pH was 5.8, so slightly acidic. So for the first experiment, we used all 12 biochars. The dose was 5% of the soil dry weight, which was 8 kilograms. And this was all mixed and placed in pots in a greenhouse at 30 degrees Celsius. Fertilizer, the control was soil without biochar. Fertilizer was added to all the pots, and 4 maize seeds were planted in each pot. So the experiment ran for 6 weeks, and each week leachate, which is the water drains from the soil, was collected, and it was analyzed for DOC and nitrate using a spectrophotometer, the instrument shown on the right. Soil total carbon and nitrogen were analyzed with the CHN analyzer, shown on the top right, and the above and below ground biomass were collected at the end, weighed, dried, and fresh. And that's just a photo of me with our largest maize stalk, shadow length greater than my height. I just thought that was funny. So now for some results. So in this graph, I'm just showing the above ground dry biomass by treatment. For this graph and the following graphs, the effect of the biochar on the variables that I described earlier was determined using analysis of variance. Where treatments were significant, a post-hoc Tukey test was carried out to compare the means of the treatments, and a post-hoc Dunnett test was carried out to compare the control with the treatments. And the control is shown with the dashed line. So in this graph, there are a lot of letters, but the main points that I wanted to show are that there was these two distinct groups. The cotton and swine manure biochars had the lowest biomass, while the filter cake and eucalyptus biomass had the highest. They were not different from each other, and they were not greater than the control. But again, we weren't really expecting the biochars to be better than the soils without the controls, because they all had ideal conditions. They all had fertilizer and enough water. But between the biochars, you can see that there was quite a bit, pretty big differences. And there's also a trend you can see for cotton and swine manure biochars. The biomass decreased with increasing temperature of pyrolysis, while for filter cake and eucalyptus, the biomass increased with increasing temperature of pyrolysis. And this was quite clear just looking at the plants. You can see that the cotton and swine manure plants had much less biomass than the other two biochars and less than the control. And again, you can see the trend of lowering biomass with increasing temperature, and for eucalyptus and filter cake, increasing biomass with increasing temperature of pyrolysis. So we suspect that the reason why the swine manure and the eucalyptus, and the cotton biochar has such a negative effect on the plant growth is probably related to the soil pH. We know that biochars do have a liming effect on soils. They increase the soil pH. And we could see that for all the biochars, they increased the pH. The soil with no biochar had a pH of 5. So all the biochars increased. But ideal pH levels for plant growth is between 5.5 and 7. And we can see that eucalyptus and filter cake biochars were still within that range. They were just up to 7. Whereas cotton and swine manure biochars were definitely much higher than 7. And the cotton 500 and 600 in particular were pretty high, 8 and 8.3. So this high alkalinity can affect nutrient availability in the soil. So probably that caused the plants to suffer a bit. In this graph, we have a percent total carbon. All the biochars significantly increased carbon in the soil compared to the soils with no biochar. The ones that increased the most were cotton and eucalyptus biochars, followed by swine manure and filter cake biochars. And there were no differences between the temperatures. For available water in the soil, we can see those two groups again, swine manure and cotton biochars, had significantly more available water in the soil than the control, whereas filter cake and eucalyptus biochars did not significantly increase available water, and they were not different from each other. And cotton had the most available water. For DOC, these two groups again are visible. Cotton and swine manure biochars had significantly higher DOC levels in their leachate compared to the control, whereas filter cake and eucalyptus were not much higher than the control, and they were not different from each other. And cotton biochar had the highest levels of DOC in their leachate. Nitrate had a similar trend to DOC. Again, cotton and swine manure biochars were significantly higher than the control, whereas filter cake and eucalyptus were not. And cotton had the highest nitrate levels in the leachate. And there were not much differences between the temperatures. If we look at DOC and nitrate over this per week, we look at both DOC and nitrate, the cotton in red and the swine manure in purple. They started off very high at the beginning, and then they tapered off towards the last few weeks. Whereas eucalyptus and filter cake biochars remain pretty much the same as the control and pretty stable throughout the 6 weeks. And this was similar in the nitrate, except in the last couple of weeks, there was a slight increase in nitrate levels in the leachate of all the biochars except for cotton, which continued its downward trend. But we suspect this is probably due to the fact that we added urea, a nitrogen fertilizer, in weeks 3, 4, and 5. So probably by the 5th week, the soil was a bit saturated, so there was some nitrate leaching. So in conclusions, we can say that the 5% dose was definitely too high. for, not for all the biochars, but for the swine manure and the cotton biochars in particular. And they not only stunted the plant growth, but they also caused some toxicity, as was evident in the yellowish kind of bird-looking leaves. So this just emphasizes the importance of finding the right dose for your specific type of biochar before you add it into the soil. DOC and nitrate losses from the cotton and swine manure biochars may be of concern at initial applications because the leachate was very high at the beginning. For our soils, this might not be too much of a concern because the arenopros in Mato Grosso are very deep, so the DOC nitrate will not, they likely will be consumed before they will reach the ground. But for other areas where the soils are not very deep, this would be something to consider before adding cotton or swine manure at this higher level. Then for eucalyptus and filter cake biochars, they did remain more stable in the long term. So they remain pretty stable throughout the 6 weeks. The cotton and swine manure biochars, although they did have high DOC and nitrate levels in their leachate, they also had the most potential to increase available water in the soil. So again, that just emphasizes the need to find the right dose so that you can use the benefits of the biochar and minimize their negative effects. And lastly, the cotton and eucalyptus biochars increase total carbon in soil the most, but all biochars in general increase the carbon levels. So the main points of this study were the importance of the dosage and also the role of the feedstock. The feedstock type seemed to play a much greater role than the temperatures. So when we moved on to the second experiment, then we narrowed we went down from 12 biochars to just four biochars, the 4 types at one temperature, and then we had different doses to try and find the best one, which in the end was much lower than 5%. So implications of this study are, firstly, each biochar has its own benefits, and they can all be tailored to the farmer's needs. So it's important that the farmer first test the biochar that they're using, find what its benefits are, and then find the right amounts to add to the soil. Biochar application can improve soil resilience. We saw that they all increase carbon levels in the soil, and some of them increase available water. This is of particular interest for Mato Grosso because the crops there are all mainly rain-fed. They don't depend on irrigation. So there are changes in precipitation patterns due to regional climate change. It's good that the soils will be able to resist any droughts or unusually long dry season periods so that the crops can still manage to survive. And lastly, transforming crop residues into biochar reduces waste. It gives them a new purpose that can be more environmentally beneficial and sustainable. And it helps remove carbon from the atmosphere by holding it in the soil. So with that, I would like to thank my funding sources, both in Brazil and in Canada, the Grupo Bom Futuro for letting us use their soils and crop residues. And there were a number of people that helped me with this project, with setup, design, just general support, more people than I can list. So with that, thank you very much for your attention. Yeah. Yeah, well, as I mentioned, that people do that, but because with the heat, these materials decompose a lot faster, and so there's a lot more emissions, and you have to keep reapplying them. So by turning into biochar, you're not only reducing all this material, but you can just apply a little bit, and not so often, and you have the same results. You'll have less carbon loss, and it's more stable, holding more nutrients, more carbon in the long term. Yeah, definitely. That's one of the things we realized afterwards that, yeah, some of them had good things, some of the others, so we thought, why don't we combine them? So yeah, that would definitely be. Also, there's been studies that combine with clay or with a little bit of compost or things like that. So I think adding just the biochar with nothing might be, with nothing else, is, yeah, might not be so good. Mixing it and finding the right amounts is better, right combination. I've seen some studies on that, but I haven't really paid too much attention about it because it's not really what I'm looking at. But yeah, there are a lot of studies on that. Yeah.
Just wondered, do you have an idea about why affordable companies don't follow
I think it has to do with the linen content. Cotton and eucalyptus, they're more woody and they have more linen than the other ones. So the porosity of them changes also with the temperature. Some, oh, sorry. With the temperature paralysis also, we did some like NMR studies and we could see the structure changing as well. The fibers for the cotton especially, the fibers would disappear and they would turn more into like the porosity would increase and so they would hold more water as well. So yeah, I think so. For the second one, well, that was looking at the doses, and the doses for eucalyptus and filter cake, they still did pretty well with the high doses, but for cotton and swine manure, the smaller the dose, the better. Finally, it was just around like, so we started at 5%, and we went down to 0.5%, and that was the best amount really, just a very, very small amount.